So the next section is actually solving these rational equations. And what you want to remember is that whenever you're solving rational equations, your ultimate goal, or the easiest way for consistency, is to be able to cross multiply in the end. And remember, in order to cross multiply, you need a fraction. So a fraction equal to another fraction. Single fraction equal to another fraction. So looking at number 10, I can already see fraction equal to fraction. Well, that's easy. Just cross multiply. Or you know it as the butterfly method. Yay, here's a pretty butterfly. Yay. Ooh. I'm so pretty. Okay, so whenever you cross and multiply, you multiply the diagonals and you set them equal to each other. A times 6, that's just 6a. Set that equal to 3 times a minus 4. Okay, let's simplify. So first, let's simplify this side by distribution. That means that this 6a is still chilling. 3 times a is 3a. 3 times negative 4 is a negative 12. And, well, I have variables on both sides of my equations. I only want it on one side, so let's move it over. So move the smaller to the larger. That's the easy. So to move 3a over, you subtract 3a. Subtract 3a. 6a minus 3a gives you 3a. 6 minus 3 is 3. And that's still equal to a negative 12. And there's a one-step equation. Divide both sides by the coefficient. Divide by 3. Divide by 3. Bam. Cancels out. A is equal to negative 12 divided by 3, which is a negative 4. Your answer is A equals a negative 4. Looking at number 11, well, I don't have a fraction equal to another fraction. That means I need to simplify this side down to one fraction. How do you do that? Well, just like the last section, least common denominator. Yay!
Oh, nothing. Spider.
You don't like spiders?
No.
What if I said there was one on your head? Alright, so that means we just got to simplify this down first. So in the meantime, this guy over here, 1 divided by 21, it's just going to be chilling. Alright, so my least common denominator, well, if you're not sure, just multiply them. What's 3x times 7? Well, that's just 21x, and that's precisely what I'm going to be using for my common denominator. You can do that all the time. It may not always be the least common denominator, but it's a denominator that works if you convert the fractions appropriately. Alright, in order to get from 3x to 21x, what did you have to multiply it by? You had to multiply it by 7. So that means 8 times 7 is 56. In order to get from 7 to 21x, you had to multiply by 3x. So that means 3x times 2 is 6x. So you can pretty much say this one was times 7, this one was times 3x, times 7 over 7. This is times 3x over 3x. Pretty much just multiplying both sides by 1, which doesn't change anything. So this guy's still chilling. Alright, now that it's under a common denominator, let's combine it into one common denominator. So then, over here, 56 minus 6x is equal to 1 over 21. Now I have a fraction equal to a fraction. You can cross multiply, but I'm going to show you a way that you can make it a little shorter. You can cross multiply and it'll always work, but here's a little shortcut. To those in my class, I gave you this property. Let's say I have x over 4 is equal to 1 over 4. Well, what is x equal to? Well, x has to be 1, correct? Because 1/4 is equal to 1/4. So the property that I told you guys is if the denominators are equal to each other, that means the numerators are equal to each other. X equals 1, which is exactly what we said. So I can actually force this denominator to be equal to this denominator. What do you have to do? Well, just multiply it by x. But remember, we don't want to change the value of it. If I multiply the denominator by x, I have to multiply the numerator by x. Ah, okay. So now the denominators are the same. I can ignore them and just look at the numerators. I'm going to move this over here. So rewritten, this is just 56 minus 6x is equal to x. So I have variables on both sides of my equations. Just move the smaller to the larger. Add 6x to both sides. So you are left with 56 is equal to, well, x plus 6x is 7x. And 7 times what gives you 56? 7 times 8 gives you 56. So your answer is simply x equals 8. Moving on to number 12. Here, I want a fraction equal to another fraction in order to cross multiply. So that means I've got to simplify this left side first. And in order to simplify, I've got to have the same denominator, but these are different. Well, the easiest way to make these the same denominator is to put a 4 over here. But, oh, I don't want to change the value of it, so if I multiply the denominator by 4, I must multiply the numerator by 4 as well. 9 times 4 is 36. So this is really going to be a 36 on the top. So let me rewrite it all combined. This is 8 over 4y plus 36 over 4y. Is equal to 1. Now I still want to combine this into one fraction. So, well, now that I have the same denominator, why don't I just write the denominator once and combine the numerator? 8 plus 36. I can't math. What's 8 plus 36?
44.
Oh. It's 44.
Since I can't do basic math.
Okay. So put that over 1. Now you have a fraction equal to a fraction. Now you can cross multiply your butterfly method. Yay! So 44 times 1 gives you 44. You set that equal to the other diagonal multiplied. 4y times 1 is 4y. And there you have a one-step equation that you already know how to solve. Divide both sides by the coefficient. 4 divided by 4 cancels. And you're left with y is equal to, well, 44 divided by 4 is 11. So your answer is y equals 11. Moving on to number 13, we have an equation, a rational equation, and
Mickey Mouse can do number 13.
No, go away.
No!
Right, so again, given this equation, I want to simplify this down into a fraction equal to another fraction. But I have two fractions here, so let's reduce and simplify this one. First, let's factor whenever possible. Always factor whenever possible. Looking over here on this denominator, I feel I can factor this. Let's use the AC method. A is going to be 1, B is 6, and C is 8. Those are my coefficients. So A times C. I want two numbers to multiply to give me 1 times 8, which is 8. But those same two factors to add up to give me my B value 6. And the numbers that work are 2 and 4. 2 times 4 is 8, and 2 plus 4 is 6. So what this really is 8 over x plus 2 times x plus 4, if I rewrite it, plus x minus 2 over x plus 2. And actually, let's put this also under the common denominator. X plus 4. Alright, so now we need a common denominator. So our common denominator, as you can see, well, let's just go ahead and, our common denominator is going to be x plus 2 times x plus 4. Because this fraction over here has an x plus 2, and this fraction over here has an x plus 4. And if you multiply them together, they'll give you x plus 2 times x plus 4. So might as well just use this one. So let's rewrite everything with a common denominator. I have 8 over x plus 2 times x plus 4 plus this x minus 2 times x plus 2 times x plus 4 is equal to 3 times x plus 2 times x plus 4. And you can find the common denominators for all across, even including the equal sign. That'll just make your steps shorter, so you won't have to cross multiply in the end. But first, I need to convert the fractions, make sure I didn't change the value of any of them. Well, from this fraction to this fraction, well, it's the same. From this fraction to this fraction, my denominator is lacking an x plus 4. So if I multiplied this denominator by an x plus 4 to get this, that means I have to multiply the numerator by x plus 4, so that I won't change the value of it. Same thing over here. This denominator is lacking an x plus 2. So you're going to put an x plus 2 up here so that it won't change the value of it. So let's go ahead and simplify. Well, all the denominators are equal to each other. Might as well just cross them out. Because if the denominators are equal to each other, then the numerators are equal to each other. Alright, so let's simplify this down. I have 8 plus, well, I can FOIL this out. X times x is x squared. X times 4 is a 4x. Negative 2 times x is a negative 2x. And a negative 2 times 4 is a negative 8. And over here, I can distribute. 3 times x is 3x. And 3 times 2 is 6. So this looks really complicated, but first let's combine like terms. So x squareds, there's no other x squareds on this side. All of my x's, 4x minus 2x, that's a positive 2x. And then 8 minus 8, well, that's just 0, so I don't even have to write it. And so that equals 3x plus 6. Well, how many different types of terms do I have? I have 3. I have x squareds, I have x's, and I have naked numbers. So we're going to move all 3 to one side. So minus 3x, minus 3x, minus 6, minus 6. Keep it balanced. So then what I'm left with is x squared minus x minus 6 equals 0. So you can solve this quadratic one of many ways. You can use the quadratic formula. You can use the AC method or factoring. You can use the square root method. You can use your graphing calculator. I'm going to use the graphing calculator because that's the route that a lot of people like to go. So let's just go ahead and plug this into our y equals. So this is x squared minus x minus 6. And I'm going to graph it. And we want to see where it crosses the x-axis because that's when y equals 0. We want to find where they intersect. You go to second trace, find the zeros. Or you can look at the table. Your first 0 is at a negative 2. So x is a negative 2. And your other 0, left bound, press enter, right bound, enter, enter, is at a 3. X equals 3. You can use this function, or you can look at the table, second graph, and find when y is equal to 0, which is at 3, 0, and negative 2, 0, which is exactly what we said here. But remember, if you have more than one solution, you want to check for extraneous solutions. So how do you do that? Plug it into any one of the denominators and see if you get an undefined. Well, let's look over here. If you plug in a negative 2 in place of x in the denominator, negative 2 plus 2 is 0. Can you divide by 0? No! This is an extraneous solution. It is impossible. And if you were to plug in a 3 in any one of these denominators, you'd get a real number. So this is fine. So your real answer is x equals 3. So be careful, especially when you have more than one answer. Make sure you check by plugging it into your denominators and see if you get anything equal to 0. Because you cannot have a denominator being 0. Because you cannot divide by 0. So for number 14, we have an application problem. But really, we also give you the equation, so you don't even have to look at the words. Pretty much we want you to solve for x, so we're just going to do the same thing that we have been doing with the rational equations. Simplify the side with multiple fractions, cross-multiply, and solve by any algebraic means. Okay, so first I've got to simplify this left side. In order to do that, I need a common denominator. Well, if you can't figure it out, just multiply. Let's let my least common denominator be these two multiplied. So that's just going to be x times x plus 20. Okay, so let's put them all over that common denominator. X times x plus 20. X times x plus 20. And I still have a 120, and I still have a 300. And I still have this 10 chilling over here on the right side. Okay, so I don't want to change the values whenever I'm putting a common denominator. So what did I multiply the denominator by to get this new denominator? I multiplied by x plus 20. So that means I have to multiply the numerator also by x plus 20. So I don't change the value of it. Same thing over here. What did I multiply this denominator by to get this new denominator? Well, I multiplied an x. So you have to multiply the numerator also by x to not change the value. So now that you have a common denominator and both fractions are equivalent to the ones above, just combine them over that same denominator and simplify the numerator. So as you can see, I put it all over the same denominator because those are the same, and then just combined my numerator. But then at this point, I need to simplify this down. So then that means I just got to distribute and then combine like terms. So still this equals 10 is still there, still chilling, and same thing with this denominator. So let's multiply this out. 120 times x is 120x. 120 times 20 is 2,400. And then I still have this plus 300x. Alright, well, I can still simplify further because, look, combine like terms. 120 plus 300, that's going to be 420x plus 2,400 over x times x plus 20 is equal to 10. So then at this point, I can cross multiply because I have a fraction is equal to another fraction. So let's go ahead and cross multiply. So here I have 420x plus 2,400 times 1. Well, that's just that quantity. And so that's equal to 10 times x times x plus 20. So that means on this right side I've got to distribute. So that means on this right side I've got to distribute a 10x. So this side is still going to be chilling. So 10x times x is 10x squared. 10x times 20 is going to be a 200x. So then how many different types of terms do you have? Well, you've got 3. You have an x squared, x's, and then naked numbers. So we're going to move it all to one side. So I'm going to choose the right side to keep the x squared positive. It doesn't really matter, but for consistency. Minus 420x on both sides. That'll move that one over. And I'm also going to subtract the 2,400 from both sides. So then that'll leave me with 0 is equal to 10x squared minus 220x minus 2,400. So here's a quadratic that we need to solve. So there are multiple ways you can solve this quadratic. You can use a quadratic formula, factoring, the square root method, whichever one works for you. So I'm going to just factor this out, factor out a 10, because all of these have at least a 10 in common. 10 times x squared gives me 10x squared. Factor out the 10, so that's 22x, and then this is minus 240 equals 0. So what you can do is you can plug this into your graphing calculator, like I did here, under y equals, and we want to find where it crosses the x-axis. So as you look on your graph, you can see it crossing on the negatives. But according to the situation, there is no negative. You can't really have a negative speed here in Algebra 2. So let's go to our table. Second to graph, and we're going to find, so it may take some scrolling, we're going to find when y is equal to 0. And that occurs when x is 30. So then x is equal to 30. So how fast did he drive? He drove 30 miles per hour. On to number 15. Again, we're going to be giving you the equation. You can read it, but we already set it up for you. So again, you're just going to simplify this left side by getting a common denominator. Well, common denominator, I'm going to use a 6t. Just multiply it. Least common denominator, let's just use 6t. So that means I have to multiply 6 by t, but then multiply the numerator by t. For this one, that means I have to multiply the denominator by 6. That means I have to multiply the numerator by 6. So that I can keep it balanced. So this right side is still chilling. So because I now have a common denominator, I'm going to put it all over that common denominator and combine the numerators. What's 1t plus 6? Well, that's just t plus 6 because, well, those aren't like terms and we don't know what t is. So now we have a fraction equal to another fraction. You can cross multiply. Remember, that's our ultimate goal. This times this. I have 4 times t plus 6, the diagonals, equal to the other diagonal, 6t times 1, that's just 6t. So let's go ahead and simplify this by distributing on the left side. 4 times t is 4t. 4 times 6 is 24. And I still have 6t. Well then, I've got to solve this equation. Well, I've got t's on both sides of my equation. I only want it on one side when I want to solve. So bring the smaller to the larger. So minus 4t minus 4t. So then you're left with 24 on this side of the equation. And then 6t minus 4t is 2t. And when you divide both sides by the coefficient, you get t is equal to 12. So the answer is 12 hours. Okay guys, so I hated the fact that we already set up the problems for you. So on the last example, I made a problem so that it would force you to actually set up the equation and then solve. Alright, so Jimmy here painted his fence red and it took him about 2 hours. Janie hated the color and painted over his fence in the color blue because I love blue.
We have the gaudiest fence in the world.
It took me 2.5 hours. Jimmy was enraged. Oh, I worked so hard.
What's enraged?
Yes. They argued and eventually agreed to work together to repaint the fence purple. How long would it take for the both of them working together to paint the fence purple?
And how long after that did it take for the neighbors to egg our fence?
Shut up. Purple's pretty. Okay, so what you want to remember about these is the first person, let's say this was Jimmy, and then this is me,
You are not drawing pictures, no, okay.
I am not drawing pictures. And this is me. And here's a fence. There's a fence. 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 Beautiful fence. Okay, so here's the basic format that you want to remember. Job over hour plus job over hour is equal to total job over hour. So this is Jimmy's rate, this is my rate, and this is the total. So how many jobs were there, or how many fences were there? Well, there was just one. How long did it take Jimmy to complete the fence? Well, it took him 2 hours. Okay, that was the first one. Bring this one down. I had one fence to paint, and it took me about two and a half hours. So working together is still one fence, but I don't know how long it'll take both of us. So we're going to call that T, or you can call it X, or you can call it or you can call it smiley face. It's just your variable that you want to solve for. I'm just going to call it T for time. So there's our equation that we want to solve. So again, with rational equations, simplify so that you have a fraction equal to a fraction. So I've got to simplify this down into one fraction. So I don't know what the least common denominator is, so I'm just going to multiply. 2 times 2.5 gives me 5. Okay, so I'm going to put it over the common denominator of 5. 2 times what gives me 5? Well, 2 times 2.5 gives me 5. So I'm going to multiply the numerator by 2.5. 2.5 times what gives me 5? Well, 2 times 2.5 gives me 5. So then I'm just going to put a 2 is equal to 1 over t. So now that I have a common denominator, I'm going to put it over that one denominator and then add the numerators. 2.5 plus 2, well, that's 4.5. And I still have 1 over t chilling on the right side. And now that I have a fraction equal to a fraction, I can cross multiply. Yay! 4.5 times t is 4.5t. 5 times 1 is 5. And now you have a one-step equation. Divide both sides by the coefficient, in this case 4.5. You get t is equal to, which is 1.1 repeating. So that's about approximately 1.1 hours. So it took him 2 hours and it took me 2.5 hours. But if we work together, it takes almost just 1 hour.